All right. Well, welcome everybody. Thank you all for taking the time to join us. We think that you will be pleasantly surprised with what you're going to learn this morning. Also, we are going to be recording this, so just so everybody's aware, as you ask questions and things like that, those will be posted in the Q&A section. I'll go through that in a second. So here's a little bit about the agenda. I am Lori Cavanaugh. I'm one of your presenters, and I will introduce the other presenter here in a moment. We are going to be talking about AI, artificial intelligence, and specifically the Apera AI vision system and how it can be utilized for robotic guidance and intelligence. We're actually not just going to tell you, we're going to show you. So I always say a picture is worth 1,000 words, and a movie picture is worth about 10,000 words. So we've got some videos to kind of show you the different applications. A little bit about what we've done at eTech with the vision systems and integrating with HMI, PLC, and a cobot, and then field your questions. So again, the presenters, I'm Lori Cavanaugh, so I am our VP of Business Development at eTech Group. I'm going to tell you a little bit about eTech Group, but more importantly, why Apera AI and why we chose to partner with them for this pretty revolutionary vision technology. Nick Hobbs is a senior regional sales manager with Apera AI. He joined them, I think it's almost a year ago, and I'll be handing the mic over to him as he talks a little bit about their applications and shows some of the cool videos. So a little bit about eTech Group. Some of you who are attending may have been aware of us as eTechnologies, a 25, 30-year-old company, but we've grown a lot. Grown up a lot, I guess, in the last 5 years. So we do serve 50 of the top Fortune 500 companies, but also a lot of other clients across not only the US, but in Canada and Mexico. We are delivering full turnkey automation solutions. We've just created a small list there to show you, but the most exciting thing for us, I think, is the ability to deliver projects from $3,000 to $30 million. We can't just do that alone. It truly does take teamwork to make the dream work. So we have a certified automation program or partner program. And that's where Apera AI, we met them last year, I want to say in the spring, became aware of this technology and thought this is truly transformational. We had tried to do vision systems in the past, and as we go through the presentation, you'll see why we tended to avoid those. There were a lot of limitations and mitigating factors, but I'm happy to say that Apera AI has become one of our certified automation partners, and I'll be kind of commenting as Nick goes along, but you'll see that it really has taken a lot of the challenges away from applying vision technology. Nick, I'm going to hand it over to you to get going on just telling our audience why this technology is so great.
Absolutely, thank you. So again, we are Apera AI. For those of you that are not aware of what we do, what this is 4D vision guidance, both for and not for robots. It really depends on your application. But the way that our system works is that you have, in this scenario in front of you, you have 2 camera sets that are mounted overhead. And they are looking down at, in this case, 5 different bins and a red dunnage in this case. And what we are doing is we're seeing a lot like human eyes. So we see 2D first. As you look in front of you at your phone, your business card, a coffee mug, you see the 2D outline first. And then what your brain does is it comprehends a 3rd dimension. That's exactly the way that our system works. So our cameras see 2D first. Our brain, our PC, comprehends the 3rd dimension. But I mentioned 4D, and that 4th dimension is AI. And the way that this works is you have 5 different Chrome socket sizes in front of you. All 5 of those sizes we would take into account their CAD files. Also the end of arm tooling, that CAD file, and then the dunnage, the red packaging, we're going to take that CAD file. We take that along with some other information, we plug it into our AI. And over the period of about 1 million digital cycles, it learns your entire process, your part, all the way through. And it self-programs. It gives you back a full-blown vision program. There's nothing to program at that point. and it's very resilient compared to other systems, and I'll dive into that. So until now, vision has come up short. I'm sure a lot of you have had the ability to use other systems, whether that be something that needed a lot of expertise with a vision engineer and possibly a robotic engineer at the same time, passing back and forth information. This is pretty typical. I've worked in integration for the past 7 years prior to this, which is actually how I met Lori, and I'm sure she can touch on this as well, on the expertise that is needed to not only train the systems that are out there, but implement them on site.
Yeah, Nick, I think, this is a great point because a lot of our clients, we're going into older manufacturing environments. They can't always, one, it's difficult to afford the high visibility, high lighting. Two, they are dealing with bins of parts, but the labor shortages have really driven I guess the demand, and also, the need for how do I take what had been a manual process but used humanistic vision to make determinations on what to do next. And that's what was so exciting about the Apera AI, because what was not possible before because of lighting, because we don't have the ability to singulate product, because we don't have the room in the facility, we have to be able to work in a small confined area, we have to replace manual, like this solves those problems. So that's the biggest thing that kind of made us really excited about jumping back into vision.
Absolutely, and Lori touched on it. This is something that is different than all others. Yes, it programs itself with AI, which yes sets us apart from others. But there's other issues here. Other systems are very slow, so the cycle times don't make sense to replace people, like Lori was speaking of. Lighting issues in the environment. If you put it next to a window or a bay door or something of that nature, maybe it's a shiny part. Other systems struggle with that. Our system actually is resilient to lighting, which I'll get into here shortly. It also is the fastest of its kind. Again, I'll get more into that later. But the scalability of this as well, Lori, and I know with other systems in working in integration in the past, if you wanted to put a secondary camera set out there, or a third or a fourth, you are doubling and tripling the price of the system, whereas ours is very, very scalable. It's mere thousands of dollars to add part-wise, and it's very simple to scale as far as the vision aspect goes, as far as programming. So I mentioned the resilience to lighting. In our system, this is part of our patented technology. If lights go out, if lights change, you're looking at clear objects here. We do very shiny objects that you saw on the very first slide. There's many different aspects of this, but lights can go completely out for us. As long as you yourself can see, we will be able to see. So there needs to be some sort of ambient light, but light changes. I know that sounds foreign, but I promise you light changes do not affect us. And it's not only that, we do not use lighting. So you will not see an array of lights. You will not see ring lighting or anything like that nearby. You won't even see a hood over our system. It is the first of its kind, and right now it's untouched. And then speed, mentioned speed earlier. So 0.3 second vision cycle is pretty incredible. So from capture through process to send to the robot, we are at about 0.3 seconds. So what does that mean for you and your system? That means now the robot is the bottleneck. It's not the vision system. That is another foreign thing that is out there. This system now unlocks the potential to applications. We've seen applications with Delta robots with 1 second cycle times when the application fits. Your typical industrial robot typically can run, 3-4 seconds, depending on what a bin would look like if you were doing a bin. But also in this scene, I do want to point out, we are not only picking these very fast, we're orientating them properly, not even just in the shape method, but that very last placement, we're looking at the etching of that part when we place it. And then process capability. So we can see things with our system that we get sub-millimeter level precision and accuracy. We showed you a lot of picking earlier. This is more of a placing application. Overhead of a very large FANUC robot that you see here, we have multiple camera sets looking at about a 6 by 6 foot area. And it's placing these small clips on these clip towers. This is not only something that you can put into, automation that is being newly bought. You can actually retrofit systems such as what you see here. This was point-to-point programming, and we replaced this system with our system, and we got rid of about 20% defects daily from that system. We now virtually have no defects at this point. And that is something that eTech would be able to help you with as far as not just your new builds, but your retrofits as well. So AI-powered vision intelligence, how does it work? Basically, the way that it works is, let's just talk about the case of bin picking. You take the robot to a place point, which we call our strike point, either next to the bin or over the bin. And then you query our system to give you the 6D pose in space of that part. We also give you the path down to and path back away from it. We also are giving you the grasp planning. So in some of these, you're seeing suction and magnetic, but we can also do, finger jaw grippers. We can do specialized grippers, whatever it is. We know what that gripper is because of this of the CAD file. But we're also doing collision avoidance with the bin walls in this case. And then object orientation, as you see, we're placing the part into the packaging in the downright manner. So that way, when that is flipped back over, you're going to be able to see the brand as the consumer. But what I do also want to point to is what's on the right-hand part of the screen. Very often we get placed into the bin picking world, right? And it's because we're the best in the world at bin picking. It's really not close. But what else do? We do machine tending, assembly, packaging, kitting, mixed SKU to palletizing, inspection, absence presence. I'm doing welding applications, dispensing applications. We're doing applications that don't involve robots. And it's more of a is it there, is it not there? A stack up that eTech is doing. The possibilities are endless because of how fast it is, the resilience to lighting, and really, honestly, you don't need the vision engineers any longer to be able to take care of this. Those vision engineers can go pay attention to something else now. This really opens up the world of possibilities. So we can de-risk your project model. The way that it works is, again, we scan the parts in with CAD models. The AI learns it over about 1 million digital cycles, and then we give you back the pipeline, which is really your vision program. But on the right-hand part of your screen, you will see what we call our digital presentation. And what this is doing is simulating your parts. So on the left is your bin, your parts. You'll see somewhat tiny, but the blue squares around the parts are what we deem as possible picks. Red squares are what we deem as impossible picks. They're occluded, they're bound, they're covered. And the pink one that's shaded, that's the one we're targeting. On the right is your robot, your end of arm tooling, and you're seeing it. It's not real time, but it is showing you how we are picking. And on the left, you'll actually see those parts disappear. What is really crazy about this is the parts on the left, the bin on the left, that's not real. That's synthetic data. That is all done by our AI. But we can deliver this to you along with other pieces, your vision cycle, your accuracy for your poses, your accuracy for the translational accuracy, and other things, all packaged up to be able to tell you, yes, we can pick it, and at what rate, and no risk at that point. And this is going to be something that eTech can help you to do.
All right, so now I think it's my turn to talk a little bit about the fun that we had putting together our demonstration of the solution. While it looks like fun and games, there's a lot going on here. So I just want to do some call outs here. Let's start with the upper right. So we talked about scalability to larger areas with more cameras. You notice there is no additional lighting here. As Nick mentioned before, there's no lights on this demonstration. We're just using office lighting. We could run this in low light. So that was a key thing. So we just have two cameras that are looking over the field of view. If you don't go down to the right, the placing on a movable target, we're going to talk about that here. We've got some videos, and I'm going to introduce a guest speaker to present on the videos. But we wanted to be able to show that that the system was smart enough to find the target. It was trained on the target, and it'll look for the center point. Continuing down in clockwise rotation, it knows good versus bad putts. So we added sensors at the end of the putting green to determine, was the putt made or not? And, robots never lie. So our cobot, who is affectionately named P3 for pick, place, and putt, will tell you, whether it was a good or a bad putt. We're picking from multiple ball patterns. So while we can train on a common object or size, it can differentiate small, variations. So in this instance, there's 4 different ball patterns. Continuing up around, in that clockwise rotation, the full integration. So an HMI, where you pick the ball that you would like to putt. It works with the cobot, works with the Apera AI system, determines a pickable ball, and then we'll go and find the target. So pretty cool demonstration. We think it's engaging. It also tells the full story of why the Apera AI system is so powerful. Before we get into the actual details and showing some of the setup and everything that we've done, Nick, did you want to add any other comments or thoughts to this?
Yeah, I think you did very well on the scalability here. So we can have up to 5 different camera sets to either get a very large field of view, or maybe you have 5 different applications you're doing. Here you're doing one, and maybe we can do others along the way with up to 2 robots on that system. But this is a great setup, and I think Lori and her team are going to show you exactly the power of what Apera AI is able to do here.
Absolutely. So I'm going to introduce my guest speaker. So he's in this picture. He's the one running the keyboard, and I always say tickling the ivory or the keyboard, but Bradley Wright is one of our engineers, and he was integral to bringing this whole, not only the demonstration to life, but continuing to add feature and functionality. So Brad, I'm going to have you take it away, and we'll advance to the next slide, and you can speak to the demo.
So a lot of what I'm going to talk about is exactly what Nick and Lori were mentioning in the previous slides. So our setup, no structured lighting. The AI does all of the heavy lifting. We've run it in different trade shows to where we have high lighting, virtually no lighting, and no issues whatsoever. So just going over some simple system setup. This is me doing a calibration for the vision system. It's incredibly easy to do, very repeatable. If you have any issues, it's not a whole thing to go back through, recalibrate your system. It's really just a 10-15 minute thing to get everything back working how it was. So if you look on the computer monitor, it's just changing the red dots to green by having a quarter in the right area. Another thing that they make it very easy to do, which we haven't shown, is calibrating the robot itself. So we have a end of arm tool semi QR code that the cameras capture and check poses. Similar to what Nick was speaking on before, you can see what our system is able to see, what it's picking. And then, so the next one, we actually show how the robot will approach and pick the ball, what position your end of arm tool is going to be in, and how, or in what space it will be reaching. And then something Lori mentioned, the dynamic target. So our target will move anywhere inside that vision region, and the robot will pick up a ball. The cameras will see where it's at and then place it right at the center of everything. So just kind of a closer explanation of what we were seeing before. So end of arm tool, that is our suction tool that is picking up the golf balls. You can see it inside the region that our cameras are looking, the pipeline. Once again, showing the region that our pick and place target will be in. One thing that I am very, very impressed with is how easy and quick these things can be set up. as long as your vision regions are already defined, you can change, recreate many setups in very, very little time. And so we finally actually get to see it work in action. Just showing what type of balls we are picking, since there is 4 different types of balls. So we are dynamically picking based on the pattern that you're seeing on top of the golf ball. And then we'll do a second pipeline to find the center of our target and place it there. So Apera has made it incredibly easy to set up demos like this and then recreate them, take them to shows, make changes on the fly. And it's been a lot of fun to work on projects like this. And this, I wish it wasn't in slow motion. This is one of my favorite things to watch. Is you make a really, really good putt, and then the robot just kind of surprises you. So what Laura mentioned with our sensors to see if we make it or not, what we were all hoping for, the robot gives you some sense of satisfaction of making a putt.
Thanks, Brad. Appreciate that.
Yeah.
Overview. It's you make it sound so simple, and it is. The Apera AI system is quite simple. And
It really is.
Yeah. And the integration is kind of the key thing. So we talk a little bit about, I'm laughing too, because when P3, we had it out at a trade show, and there were some guys placing bets on whether they were going to make the putt. Well, the one guy got distracted. And so, he turned around and said, "Hey, did you make it?" And he goes, "Yes." And he hadn't made it. And all of a sudden P3 started to shake its head, and we started laughing. I said, "I told you, robots don't lie." So he had to pay up. But one of the things that we do, again, bringing it all together at eTech Group, it's the Apera AI engine is very, very powerful. It can give us that very quick, real-time human, vision, deterministic response. So then we know what to do, whether it's upstream, downstream, or in the operation. So this works in a lot of different, areas. It can work in process or in discrete applications. But one of the things we do at eTech is following along that same idea of envision the solution. Can we look at it digitally first? Can we prove out that it's going to work? Can we do a model of the solution? And then the picture to the right is showing, yes, we can do that, and then we can bring it to life. So what you are seeing is the exact same application, but this was before the project occurred and then the actual installation of the solution. We kind of refer to that as the whole digital lifecycle management, then supporting and maintaining the systems after the fact. It's kind of just summarizes the things that we all, we're talking about here. As part of our, CAP program, Apera AI has been a great partner. Like we said, proper planning prevents poor performance. So the more we can do digitally, the more that we can prove things out and show that there's going to be low risk, consistency, speed, throughput, then the belief is in the system, and we can go ahead and do the implementation. So we have a lot of strong adoption and use cases already in play. It offers new opportunities. I always say dust off those old projects, the projects that you might have shelved because it just wasn't feasible. It wasn't feasible from a cost perspective, all the setup, the maintenance, the support after the fact. A lot of that is eliminated with this solution. So you might just want to take a fresh look at the problem that you've been trying to solve or that you still have, and see if this integrated solution would be a solution to that problem. And then I think we're at the last slide. So we just get right to it. We leave some time for Q&A, and I'm going to maybe pass this over to Sean, or Sean, you can do a voiceover if you want.
Absolutely, guys. So we did get a couple of questions. Looks like we've got a handful more that are starting to come in. The first is, how long does it take for the AI to go through 1 million learning cycles?
So the process in which this takes place is once you submit this currently to date, you'll receive your vision program back within a week or so, typically. A lot of that right now is going to come down by the end of the year to a couple of hours. So right now, I would just give yourself a week to 2 weeks tops.
It's a quick turnaround. All right, guys, so we do have more coming in. How many different objects can the system handle at one time? And what if they have a different mix of finishes?
Yes, so that's a good question. So right now, the PC alone can handle up to 30 parts learned. So it's looking for 30 different parts. However, I also have other customers that have their own internal network, which I know eTech can help you to set up. But they do have their own network, and we have hundreds of parts learned. And it takes mere 20 seconds. If it's not part of those 30 parts, that's simultaneous. But if it's not part of those 30 parts, it takes about 20 seconds to load and go find it from that internal network. Now, as far as different finishes, I've been working with foundries and casting plants where they have, we'll call them metal billets. And then on those metal billets, we can pick clean, or we can pick some that are, corroded, and they just have a mess of different finishes on them. We don't care. We really don't mind. We can pick different colors, things of that nature. However, we're not looking for color at that point. So you just need to let us know what we need and don't need to look for here. But for that sense, it won't affect us.
And I'd just like to, I was just going to add a few comments as well, if that was okay. That there are some things too that we take into consideration. We do have our own internal industrial IT group, so we have helped companies with working with their IT groups to set up the proper, we call it OT network, right? The servers, the systems, and so we can definitely help with that as well. And just as Nick was pointing out, it's a matter of calling up the right pipelines and thinking about the operation and the process, and then deciding, is it a decentralized kind of architecture, or do we centralize it? So those types of things, great questions. It's not a limitation necessarily of the Apera AI system. It's just a matter of the delivery mechanism to their engine and how do we want to distribute that.
Great, thank you, Lori.
Mm-hmm.
So in part, I believe, to the first question of learning cycles, how long does it take to evaluate a new project before you get to that point?
Yes, so from the Apera side, that takes mere hours. Just let us know what your application is. We like to try to set up a meeting with you, typically virtually, because there's a few questions we need to ask, such as cycle time, accuracies, what does it look like when we are picking? What does it look like when we're placing? Things of that nature. So if you can give us an hour of your time, we'd love to run through that with you and get you in touch with eTech to finish off your project. Lori, I know you have a bit of a different timeline there.
Yeah. No, I think it's that ties in well with, trying to get the learnings and the pipeline built. And we want to look holistically too, is just what is it the problem that we're trying to solve, and what could potentially interfere with that, I'll call it kind of point in time where we're relying on vision. So in one scenario, we had a client where in an upstream application, they might be applying grease or oils or something like that. So if that could create a downstream issue with resolution or being able to see the system, let's help them with that upstream problem. Let's do maybe a more automated application of that grease or that oil, so we can control that look and feel downstream. And likewise, if after vision, what are we going to do? What's the determination once we get the response back from the Apera AI system? So does it need to integrate with a PLC program or some other, with a robot, with other downstream applications, and kind of tie it all together? So we tend to like to go to site just so we can really understand, the business. At least one, I always say walk a day in the steel-toed shoes, but just really understand what's going on and what vision is going to help them solve.
Great, thank you guys. Next, can you share any non-robotics use cases? Discrete product appearance, quality checks, how many images a minute can you handle?
Yeah, that's actually a great question. So our processing time, again, from vision capture through process, is less than a second. So you can get more than 60 captures a minute. We are looking at a few different applications where one is like pill bottle recognition. We're finding different bottle sizes, cap sizes. We're verifying that the correct amount is there and that the correct sizes are there. We're doing an application with a wheel hub assembly where we need to find out, that the spacer, the nut, and then the clamping mechanism is all there. And the difficulty in that aspect, there's heavy amounts of grease on that product, and it's not transparent. That is something where we're only seeing a sliver of the actual piece in some instances. There are other cases out there where we're working outside on railroads, looking for rail ties and dropping railway components. We're also doing stuff out in the solar fields and mining equipment. This, like I did mention, this does have the aspect of the ambient lighting not affecting us. So that's why we have those outdoor applications. But those are some of the non-robotic applications.
Do you need a site visit to get started?
I think that's a great question. For Apera, we do not. If we can just do a quick Teams meeting such as this, we can run through your application as long as you have pictures of the parts and or video and a good understanding of the application so that we can determine whether or not our system's a fit for it. I'm sure Lori has a completely different answer there.
I always like to go visit the site.
Yes.
But no, I think that's a great answer. I think it's not necessary, but it is always interesting too, because I love the fact that the lighting doesn't matter, but we do still want to figure out the size of field of view. Some of that stuff is kind of dimensionally oriented or physically or spatially. We want to just kind of see the environment, not because we're concerned, but just more about, okay, do we need, just one pair of cameras? Do we need two or three? What's the field of view? Are there any, obstructions? And then also look at that kind of upstream, downstream, what's happening prior to, what the vision technology is going to be looking at and after. So not necessary, which is kind of nice. Like we can just look to see feasibility first, but then it's like, okay, we've gotten through that checkbox. Now let's go and talk about the true application, the installation, and those considerations. But and I usually bring box lunch, and I make people work through lunch. So site visits are always great.
Right. And we did have a follow-up from that individual that asked the original segmentation question. They're asking to describe the computing platform, CPU, GPU, etc.
Yes, so there's nothing special about the products that we use. They are just off-the-shelf products. You can either have a Dell or a Lenovo PC specified. All of our stuff is in stock, I should mention that. But our PC, and I can get you the specs on it if it's absolutely needed. But the PC does have a very, very fast GPU in it, and it runs very hot. That's why we have a desktop version of this currently, and we're getting ready to release a smaller version. We used to have more of a rack mount version of this, and it sounded similar to a jet engine because the fans had to act so fast and they had to be so small. I can get you the exact specifications on it though, if you would like those.
He's asking, let's say I'm looking for a foreign object which can exist anywhere on the image, and that foreign object is of low contrast, white on white. Can your system handle that?
Oh, that's easy. Yeah, absolutely. We do black on black, white on white, clear objects, chrome objects. That's what we specialize in. We are the reason why we make automation projects possible. Whereas other systems, you have to have lighting tricks and things of that nature, the strobing and such. None of that is an issue with our system. We don't have to play any tricks for it. Yeah, that's a simple project. As far as finding defects, you didn't ask this, but this does bring up that issue. Currently, our system does not look for defects. If it is a known object and we have CAD of it, we can look for it. If it's not supposed to be there, we can tell you it's there. However, I can't look for scratches, dents, disfigurations, things of that nature yet. It is coming out this year. I don't know the exact date, but that will come out later.
And as it relates to the hardware question we received just a bit ago, they're asking, instead of a desktop PC, have you considered using an IPC that it can be mounted on the machine?
Yeah, the version that we're coming out with, it has an IPC look and feel. It is not IPC rated. I would suggest that it goes into a cabinet. It's just not something that we can get on an IPC yet because of I believe it's an NVIDIA GPU. It's not a fit yet for the IPCs. We are still looking.
Next on the list, you showed a video of a tier 1 automotive supplier doing assembly. What other applications of this tech have automotive suppliers validated?
The reason why a lot of people haven't heard about us is because we just hit the American market last year. And then we went to Automate last year. At that show, we met a lot of automotive suppliers. And what we found is a lot of issues right now with having a workforce available. So right now, a lot of what the automotive companies are doing are replacing those jobs and placing those people into other jobs by using our system. So by using our system, a lot like what Lori showed, by using our system with a cobot or an industrial robot, you can replace a person's job at that point in time because our system is so fast. It's not limiting anymore. We now can work as fast as an operator. So doing assemblies, kitting is another one that's big in the automotive world. The next biggest that I've seen would be CNC and machine tending. Just replacing those jobs and allowing you to put people where they are better suited and you're going to get more out of them. It has been the big deal. We also saw a very large automotive company use our system for depalletization. So they had 26 different SKUs of parts coming in from suppliers. And we were depalletizing all 26 of those. We have a very large consumer goods company using our system to look at hundreds of different SKUs of parts at this point as well. But yeah, the automotive companies are looking primarily right now at job replacement and how this can work alongside of a robot. It's about a year payback.
Yeah, I was going to chime in as well too, because I think that's a great question. And I've had a lot of long history in automotive, but if you take automotive supply chain and just look at it more broadly, any discrete manufacturer, so we have a lot of our clients that are in that kind of traditional space where they had work cells and what they're trying to do is semi-automate, right? Add conveyance, material conveyance, and then start to also add the vision and some type of whatever it is, work on the part. They're going to add to the part. They're going to do an inspection from I'll call it presence or lack thereof, and then decide does that need to be reworked at a previous operation. So it's been pretty exciting. So it's not just automotive supply, but look at it holistically as any discrete or hybrid manufacturing operation is really looking at this.
Hey, thanks, guys. Next on the list here, we have, is there a specific camera type, model, brand that has to be used?
So we suggest only using the models and brands that we have tested. There is not a specific brand that has to be used, but we do need to test it. Currently, what it does come with is Basler cameras. They're 12 megapixel grayscale stereo vision cameras. We also use Allied Vision. That does not mean that the same type of camera from some other brand couldn't be used.
Okay, they just need to go through a testing process.
Mhm.
Next is it one-to-one PC with a robot solution? You said up to 2 robots and 5 apps and cannot detect scratches. Are those the only limits identified?
So two-part answer here. With one PC, you can control up to 2 robots as long as your application allows. So if I'm doing a 1-second cycle time with your robot, it's just that robot. You took all the computing power. But if you're doing something that's pretty normal, 4 or 5 seconds, you can have up to 2 robots and up to 5 camera sets total.
And it cannot detect scratches. And they were
Yes.
curious if those were the only limitations.
So the limitations, that is one of them. There are a couple more. So we can move with moving parts, but we will want to make sure that if it's dealing with a robot, it's pretty stationary. If it's not moving with a robot, we have other ways around it. So let us know what that application looks like. We'll let you know whether or not it's a fit. But it needs some form of rigidity, the parts that we're picking. So plastic bags that can manipulate an infinite amount of ways are not good to pick. I cannot train for infinite. I can train for finite. Same thing with strings and things of that nature. That's going to be really hard to look at. Wires and cabling that are pretty rigid we can do. We did some systems with bags of water that were pretty filled, chip bags we've done, things of that nature, but it has to have some form of rigidity.
Okay. Next we have how many cameras per PC?
So it would be 10 is the limit, the absolute limit. But they come in pairs, so we need them to be pairs. So up to 5 pairs, which is why it would be 10 cameras.
Okay, no individually running cameras.
Yes, sometimes, but it's only in the 2D world, not 3D and 4D.
Understood. Got it.
Mm-hmm.
The next one we have here is where does the functionality of the Apera system end and other robotic/PLC programming begin?
Yes, so and this is what eTech's going to be able to help you out with. So in the holistic operation, all we are concerned with, we are not controlling your robot by any means, okay? So you're asking us, instead of programming the point and the path, we give it to you. You query us. However, if safety takes over, all hands are off. We don't touch safety. It will stop everything. We're just giving you the coordinates in the path. Everything else is still controlled by the robot or the PLC that you currently use today.
I might put Brad on the spot a little bit, so I'll give him a second to, but when we showed kind of our P3, demonstration, it might be interesting to kind of have Brad talk about the evolution of that as we added a PLC and HMI sensors, etc.
Yeah, so we started off with just the robot and camera system, and extremely straightforward. You get your data from the vision system, you program the robot to go to that point, and then you tell the robot where you want the object to go. From there, we added an HMI and a Allen Bradley PLC to run just a couple IO back and forth to say when it's in this position, we want this program to run in the background to count how many balls we have left, to see how many times we've cycled, to see when we need to go and clean up our collect bin. And there hasn't been a single piece, I don't think, that has been hard to integrate with a pair of cameras. Like Nick said, they give you the data, you get to choose what you do with it, and it's really as creative as you want to be, is the farthest you can go with it.
Thanks, Brad. Thanks for letting me put you on the spot.
Yeah.
Right. right, we've got a couple more pouring in here. So how is the software licensed?
Yeah, so the way that it works right now is that it comes with a 3-year license. So it's completely bundled. If at the end of 3 years you choose not to move forward with a new license, it'll still continue to operate as it was for the past 3 years. There's absolutely no need to do that unless, of course, you want added support from our side and/or access to our AI. So if you want to train more objects, you want to add and subtract from objects from that system, you would need access to that system. And I can go into pricing and whatnot with you at a later date, but that would be something that we can look at a future date.
Sounds great.
If needed.
Next we have, do you have a list of cobot manufacturers that you are compatible with?
That's a great question. I can't believe I actually forgot that earlier. So it's not just cobots, it is industrial as well. But we have up to about 12 different brands, all of your major brands that you can consider. So ABB, Fanuc, UR, Doosan, Yaskawa, Mitsubishi. I'm just trying to rattle some off. Stably, Kuka. If I'm missing any, just yell it out in the chat. But it's compatible with almost all. If you have projects and it needs to be written, it's a couple-week process. So just let us know.
Great. Circling back to licensing, they're curious, is it licensed for unlimited users?
Yeah, so you can train as many parts as you want. Procter & Gamble has thousands of parts learned at this point in time. I think they have the most parts trained. As far as what's on that system, it only cares that, up to 30 are on that system. So when you do purchase, you can have, your typical system has up to 10. You can add up to 30, however, if you purchase that one. But we don't care how many you have trained, just that only up to 30 are active on that system. So that scenario in which I said you have a local network that eTech could help provide, you can have hundreds or thousands of parts all learned on that. And we only care that 30 are active running on that PC at one time.
The last one I have here that has come in is inspection came up earlier. Our previous inspection projects always needed reference images for training. Is that the case here?
So as far as just any project, we need CAD files. If we are looking for, let's say, part presence, we need the actual CAD files of the parts and the stack in that manner. For that pill bottle application, we needed to see all different variations of, of the lids and the bottle sizes and things of that nature. It's not just the CAD, but cell phone pictures help tremendously. We like to see the finishes and things like that so that our AI can train.
Everybody on with us here, we have 6 minutes left. If there's any other questions, please feel free to enter them in the Q&A. As of now, that wraps us up here, guys. We'll give everybody another minute or so, but we just want to thank everybody for logging on, engaging, participating. Lori, Nick, thank you both for presenting.
Thank you. No, the great questions, and we will have a follow-on, a blog post as well as almost like a Q&A article, I think, because Nick, those are some great questions, and I really appreciate Nick and the team at Apera AI for helping pull all of this together and having such great testimonial videos. Like I said, it's one thing to say it, but another thing to show it. So really appreciate that.
Yeah, no, and thank you for your guys' partnership. And I think this was a great thing to have. And I hope that the questions continue to roll in afterwards.
Awesome. Thanks, everybody.
Thanks.
All right. Thank you all. You guys have a great day.
Thank you all.
Thanks.